masters in their field. World-class chefs with extreme confidence and incomparable skill. 16 all-stars fight it out in this tournament event. Only one will become the grand champion and get $75,000 for a favorite charity.
It's beautiful cooking.
All other all-stars will be chopped.
Welcome to Mendel's Baking Show. Today we have 4 contestants who will be putting their genetic baking skills together to hopefully create a masterpiece. We can't wait to try the final products. Let's hope there are no mutations along the way.
Now I'm going to add 2.5 grams of flour. For my cupcake organism, I'm going to add 2.5 cups of flour.
After adding the 2.5 cups of flour, I'm going to add 2 cups of sugar.
After adding 2 cups of sugar, I'm going to add 3 teaspoons of baking powder. Now I'm going to add 1 cup of milk. Now I'm going to add 1/2 cup of olive oil.
Okay, now I'm going to put vanilla extract. But oh shoot, I only have peppermint, or I ran out of vanilla, so now I have to use peppermint.
I don't know if you guys saw, but one of the copies of her jeans was peppermint extract. Hopefully that doesn't cause a mutation. Yeah. Now I'm going to add 2 copies of vanilla extract. Now I'm adding eggs. Obviously organic and non-GMO. Now I'm going to add 1 cup of water. Okay. Now for some energetic interaction. This looks kind of weird. It's kind of clumpy. I want my frosting to have the purple phenotype, so I'm going to add 2 copies of the purple gene.
Here's 1 copy of the purple gene. Oh, there's nothing there. Let's hope I'm haplo-sufficient.
Alright, let's make some frosting. Oh no, both copies of my purple gene aren't producing transcription factors. I don't think I'll be able to get a purple phenotype.
All right, bakers, 5 seconds left. 5, 4, 3, 2, 1. Put down your enzymes.
Contestant number 1, please step forward and deliver your vanilla cupcake organism. The flavor and texture phenotype is incredible, but why is it a white phenotype?
I've seen this null mutation before, when both food coloring genes are the mutated white allele, the active transcription factor that initiates the transcription of the purple pigment gene is not present, and no purple pigment is produced.
My food coloring genes were both mutated, so the transcription factors that bind to the telltale box of the pigment producing gene were not present. This mutation is recessive, so if one of my food coloring genes was not mutated, I would have produced the purple phenotype.
Bummer. Contestant number 2, please present your organism.
Contestant number 2, please step forward and deliver your vanilla cupcake organism. Yuck! Why does this taste like peppermint?
I encountered a dominant negative mutation in my gene ingredient box. The DNA called for 2 genes of vanilla extract, but I only had 1. The other one I used was a mutated to a peppermint gene. This one mutant allele changed the flavor phenotype of my entire organism.
So unfortunate that this is a dominant negative mutation. A mutation like this usually occurs when a product can still interact with the same elements as the wild-type product, but it blocks some aspect of its function. So in this case, the peppermint extract can still interact with the other ingredients just like the vanilla extract, except it blocks the function of the specific taste.
Contestant number 3, please step forward and deliver your vanilla cupcake organism. What is this? This is unedible, not viable, and lethal.
I did not have a sufficient amount of flour, so instead of 2.5 cups, I could only add 2.5 grams. Because both flour alleles were mutated,
Now this is a prime example of recessive lethality. You will never find a cupcake organism that is homozygous for the flour mutation. They will not develop.
Contestant number 4, please step forward and deliver your vanilla cupcake organism. Wow, that phenotype is fully functioning. It is perfect.
Well, I had no mutations in any of my genotypes. I had 2 fully normally functioning genes or copies of every single gene. So as you can see, there is the perfect vanilla cupcake organism.